Now number 2 says, as in the previous problem, so we're looking at number 1 for information, the offspring have self-fertilized. Show this in a Punnett square. Identify the genotypic and phenotypic ratios again, the type of genes and the type of what? Physical appearance. So when it says the offspring, what it's talking about is the kids, is that we had a mom plant and a dad plant had kids. They had 4 kids being plants. You can mix them back together. And it's saying self-fertilized, or if they had children. If we took 2 random people from this population or 2 random plants and made them have plant babies, what would it be? So we have the same key because it's number 1. You don't really have to write the key down again. The parents now, we know one is going to be big Y, little y, and another one is going to be big Y, little y, because we took 2 random kids out of this group, and they all have the same. Then to make a Punnett square, we copy this capital Y down. We copy this lowercase y down. We copy a capital Y across. We copy a lowercase y across. There we go. Now the genotypic ratio would be 1 YY to 2 YYs to 1 YY. And I know that looks confusing. All we did was count the number of times this happened, and we put those little dots in between them. Then the phenotypic ratio, remember, any time we have a dominant trait show up, it takes on that dominant characteristic. So we should have this one. What color will this be? We have 2 genes for yellow. It's got to be yellow. Here we have 1 dominant and 1 recessive gene. It's going to be yellow. Good, dominant. And here we have 1 recessive and then dominant gene. That will still be yellow. Anything that has a capital letter is yellow, so this would be 3 yellow to 1, and the last one would be green because it's 2 recessive traits. So 3 yellow to 1 green.